In this video, I am going to demonstrate a buffer overflow attack using SeedSlab in a virtual machine environment. Buffer overflow is one of the most important topics in cybersecurity and ethical hacking because many real-world vulnerabilities happen due to improper memory handling in programs. In this demonstration, I will explain what is buffer overflow, why we study it, what is SeedSlab, and how it practically perform a level 1 buffer overflow attack. What is buffer overflow? A buffer overflow occurs when a program tries to store more data than the memory buffer can hold. Due to this, extra data overwrites nearby memory. This can cause the return address and attackers can hijack the execution flow of the program. This vulnerability is very dangerous because it can provide root or admin access. It also remove code execution. Many famous cyber attacks happen because of buffer overflow. So we study different overflow, understanding how hacking works, learning secure programming practices, protecting systems from such vulnerabilities. So now what is SeedSlab? SeedLab is a cybersecurity education platform designed for hands-on learning. It provides pre-configured vulnerable programs, safe legal attack environment, realistic practical labs. We use SeedLab Ubuntu 20.04 virtual machine to safely perform attacks. What are L1, L2, L3, L4 levels? SeedSlab provides 4 difficult levels. So level 1, which is L1, known buffer size easily. Level 2, unknown buffer size. Level 3, buffer is too small. Level 4, strong security protections. In this video, we demonstrate level 1 attack. Practical demonstration. Level 1 buffer overflow. In the step 1, start the virtual machine. First, we start the Seed Ubuntu virtual machine using VirtualBox. After login, we open the terminal. Step 2, we need to navigate to lab folder. Now, we go to the buffer overflow lab folder. Now, we need to copy a code which is in the directory cd/home/seed/lab setup. So here we can see stack L1, which is our vulnerable program. Step 3, understanding the vulnerability. We now execute the program, copy the code, and it asks for input sizes. So based on input size, we test the different values. For example, if the input is 5, program works normally. If input is 100, program works. If the input is 400, it causes segmentation fault. This crash indicates buffer overflow vulnerability. The next step is step 4, finding buffer size. So after testing, we discovered that buffer size equals to 517 bytes. That means if we give input more than 517 bytes, memory gets overwritten. This is the key point for exploiting the program. So now step 5 is creating exploit.py. This is the main attack script. So now we create exploit.py file, which is a Python file which generates our malicious payload. This file contains shellcode, that is Open Linux shell, and NOP/SLED increases attack success and total payload size, which is equals to 517 bytes. So we write a Python code and then we execute the scripts. The scripts creates a malicious input file. And then in execution gap, we need to run few commands in the command prompt, that is python 3 exploit.py. So then we get the output. The output is shell access. So if the attack is success, we get a shell prompt. Now we need to verify by copying the code, like some who am I. So the output code would be like seeds. This confirm the buffer overflow attack, that is success, and we gain shell access. So finally the conclusion is, in this we demonstrated and understood buffer overflow attacks using SeedSlab environment and successfully exploited level 1 vulnerability, gained shell access. Higher levels such as L2, L3 and L4 involve unknown buffer sizes, smaller memory spaces, advanced security protections which are required, GDB debugging and memory offset calculations. This experiment clearly